Welcome to this video. So in this video, we're going to look at discrete random variables, okay? And I'm getting these questions from tutorial sheet 6 for those who are doing medical mathematics for second semester. So this is University of Lusaka. But if you're from any other university, you can still learn the concepts of the discrete random variables, okay? So this tutorial sheet has 11 questions, okay? And I'm going to go over all the questions, okay? I'm going to solve them one by one. So that's question 1. You can see question 2, question 3, all the way up to question 11. Okay, so if you'd like to access the full video where I'll be solving all these questions here, please feel free to register with us. You can check the link in the description, okay? It's going to show you a guidance video on how you can register for our lessons. Okay, and then from there, you're also going to find a link to our website. So you register from our website, and then you'll be able to access the full video on this tutorial sheet and also on all the other tutorial sheets that you have and the tutorial sheet that you've had already. So we have solutions to all those tutorial sheets. Please feel free to register with us. All right, so now let's go over and solve some of these questions. Welcome to this video. So in this lesson, we are going to look at discrete random variables, okay? But before we even do that, let's define what a random variable is. Okay, so by definition, we say that a random variable, okay, is simply, we're going to say an attribute or a characteristic, okay, that is being measured in an experiment. Okay, so this is what a random variable is in simple terms. It's just an attribute or an or a characteristics, okay, that is being measured in a what? In experiment. Okay, so this random variable is usually represented or denoted by a symbol. So we can say X or maybe Y, okay, or Z or whatever symbol, let's say this symbol here, okay? So this random variable can be denoted by a symbol or a letter. Okay, so there are two types of random variable. There's one, what we are going to talk about today, which is a discrete random variable. And then there's another one, which is a what? A continuous. Okay, so how do you identify that this one is a discrete and then this one is a what? A continuous. So for a discrete, you're going to be given, okay? You're going to be given distinct countable values that X can take, okay? So we can say X can be 1, it can be 2, it can be 3, and it can be 4. So since these values that this X can take is countable, we call this X as a what? A discrete random variable. Okay, and then later on, we're also going to look at what we call as the continuous random variable. So how do you identify that? You're going to be given a range of values that this X can take. So they can say X, okay, is from maybe, they say 15, from 10 to 15. Okay, so if the X takes values in an interval like this, we're going to say this here is a continuously random variable like that. Okay, but if it's countable like this one, we're going to say it's a what? A discrete random variable. Okay, so in short, we can just say a discrete random variable is actually a type of variable that takes on distinct countable values, and it's typically represented by what we call as a probability what? Distribution. Okay, so this probability distribution, it can be represented in two ways. Okay, so the first one is the table form. Okay, you can use the table form to represent the probability distribution, or you can use what we call as the PMF. Okay, so this means probability mass function. So both the table and the PMF, okay, so the PMF is just simply a formula. So we can say f of x, okay? So the PMF is simply a formula. So we're going to say this discrete random variable can be represented in a table form, okay, or a PMF. And that representation, we call it as a probability what? Distribution. Okay, so both the table and the PMF, which is just simply a formula, will assign a probability to each possible value of what? X. Okay, so this PMF, f of x, okay, can also be represented in this way. You can say P of x, okay, or you can say P for the random variable that is equaling a certain value, small letter x, like that. So if you see this and this, they're just the same. Okay, and then in a table form, we're going to represent it like this. Okay, it's just going to be a table that assigns each random variable that you have there, okay, a certain what? Probability. So we can say our random variable is x, and then here we're going to have the probability px. Okay, so we can say we have 1, 2, and then 5. So we can say, okay, this one is 0.2, this one is also 0.2, and then the remaining one will be 0.6. Okay, so we're going to say this one here is also a probability distribution, but it's being represented in a table form. So you can see that each value of the x here takes on a certain what? Probability. Okay, so that's what we call as the probability distribution. Okay, so now it's very important for us to know the properties of the PMF, okay, which is just the probability mass function. So for something to be a valid, okay, for something to be a valid PMF or probability mass function, then it must satisfy the following two conditions. So the first one, okay, is that f of x, which is the probability mass function, should be between 0 and 1, okay, for all the x values that for all the values that x can take in that distribution, okay, the f of x should be between this 0 and what? The 1. Okay, so this is the first condition. So this simply means that the probability, okay, of anything happening should always be between 0 and 1. You can't have a probability that is more than 1, and you can't have a probability that is less than what? 0. And then the second one, okay, is that when you sum all the probabilities, okay, for all the values of x that you're considering, okay, the total that you should get should always be 1. Why? Because the total probability can always be 1. Okay, so for example, if we say the probability of you passing a test, okay, is 0.5. So this is the probability for passing. Then it means the probability for failing should what? Also be 0.5. So that when you add here, you should get 1. So that's what we mean. When we add the probabilities, okay, of all the values that x can take, we should always end up with what? 1. Okay, so it's very important to know these two because we are going to be use them, okay, to answer questions. Okay, we are going to use them to answer questions. All right, and then the other thing that we need to know is how to calculate the expected value, the variance, and standard deviation, as well as the cumulative, how to calculate the cumulative probability. Okay, so the cumulative probability is actually represented by a capital letter F like this. Okay, so we're going to say capital letter F of X. So the cumulative distribution function, okay, whenever you see such, it's called the cumulative distribution function, is just a function, okay, that describes the probability that a random variable, okay, will take on a value less than or equal to a given value. So in other ways, we say that f of x, okay, capital F, always put capital F here, is the same as the probability, okay, that this random variable x will take on values, okay, that are equal to this x or less than this x. That's the cumulative distribution function or the cumulative distribution probability. Okay, so you're not considering one probability, no, you are considering the probability, okay, for some certain values that are less than or equal to a certain value. So for example, I'll put it in a table, okay, so that we can easily understand. Okay, so I'll say this is my random variable x. I have 1, I have 2, and then I have 3. And then this is my probability here. Okay, and then I say this one has the probability 0.5. This one has 0.1. Okay, it means this one will have 0.4. So that the summation should always be 1. Okay, and then the f of x here, which is the commutative distribution function, okay, or the commutative probability, will be, okay, the probability that x takes on a certain value or less than that. So the first one here, just get the same one, this one here. So we're going to say this is 0.5. And then the next one here, the commutative distribution, will be this 0.5 plus 0.1. So it will be 0.6. Then the next one to be 0.6 plus 0.4. So the next one will be what? 1. Okay. So this also tells us that the total cumulative probability should always be 1. Okay. If you find any other number here at the end, okay, just know that you've gone wrong somewhere, because the total cumulative probability should always be 1. So that's what it means here. It means this x value is taking, okay, the probability at a certain value of x, but also considering all the value of x that are less than it. Okay. So for example, here, if they told you to find f2, f2 will simply be the probability that x is less than or equal to what? 2. So how many random variables here are less than or equal to 2? We see there's 1 and 2. So this one is the same as the probability of 1 plus the probability of what? 2. So when we add them there, it's 0.5 plus 0.1. That is this 6 that we got there. Okay. So that's how we are going to be finding the cumulative distribution function, or the cumulative probability. Okay. And then the other thing, now we have to know how to calculate the we have to know how to calculate the expected value, okay, and the variance. So the expected value is simply the average, okay? You know how to find the average, right? For example, if I have 10, 20, and then 30, then I tell you to find the average of this, okay? You're just going to say the average there is equals to 10 plus 30 plus 20, and then I divide by how many they are. 1, 2, 3. So 3. Okay, and then you find whatever you find here. So this average here, under discrete random variables, we're going to be calling it as the expected value of x. Okay, so you're just simply finding the mean or the average. Okay, so under probability, we're going to say that the expected value of x is simply equals to, okay, the summation of all x multiplied by the probability, like that. Okay, so here you can write OX. So for all the x values that we're considering in this situation, okay, so you multiply x with the probability that it has, and then you add them. So simply meaning that if we had something like this formula means this. Okay, so if this is my x and then this is my px, remember I said px is the same as f of x, right? And then I have my probabilities here. Let's say for 1, 2, and 3. And then here I have 0.5, 0.1, and then 0.4, if I have something like that. So the mean there will just be multiply the x with its probability, and then plus multiply by x with its probability, multiply the x with its probability. So we're going to say 1 multiplied by 0.5 plus, okay, 2 multiplied by 0.1 plus 3 multiplied by 0.4. So when we add all this, we're going to get what we call as the expected value, okay, or the average. So this is the formula that we are going to be using when finding the what? The average, okay, or the expected value. And then we can also talk about the variance. Okay, so the variance, we're going to say variance of x is simply equals to the expected value of x squared minus the expected value of x, and then we square it. So notice that here the square is inside. It is with the x, but here the square is outside. Okay, so it means when you're finding the variance, you first of all have to calculate, okay, the expected value of x by this formula that we can see here. Okay, and then from there you have to calculate the expected value of x squared. So how do we calculate the expected value of x squared? Okay, we are going to say expected value of x squared is just equals to the summation, okay, under all the x values that we are considering, of x squared multiplied by f of x. So this is the formula that we're going to be using. Okay, so we just replace where those x here, now we put x squared, as you can see there. Okay, so when you find that value, put it here and then minus the value of the expected value of x that you found, and then you square it, and then it's going to give you the variance. Okay. And then from there, we can talk about the standard deviation. So the standard deviation is not difficult. Okay. So standard deviation, as long as you have the variance, okay, then you have your standard deviation. So standard deviation will just be the square root of the what? The variance. Okay, so those are some of the things and rules that you need to be aware of as we are tackling these questions here. So now let's look at some sample problems. Okay, so we start with this one. So here they're saying um, the discrete random variable x has the probability distribution given in the table below. So we can see the table here. We have the random variables there with their probabilities. Okay, so question 1 or question A, write down the values of f5. Okay, so remember, if I have fx, it's the same as p of x less than or equal to a smaller letter x. So this smaller letter x here is the one that represents these two numbers on top here. Okay, so what we're going to do there now is, okay, we're going to write f of 5. So f of 5 will simply be equals to the probability that x is less than or equal to what? 5. Okay, so it means we are adding all the probabilities for all the x values that are less than what? 5. Okay, so minus 2 is less than 5, 1, 3, and 4. So we're going to add the probabilities for these guys. Okay, so the probability of minus 2, or maybe first I should write probability of minus 2 plus the probability of 1 plus the probability of 3 plus the probability of 4. Okay, so I end on 4 here because this 6 is not less than 5. And then I add them now. So the probability of minus 2 is 1 over 4 plus probability of 1, 1 over 6 plus probability of 3, 1 over 3 plus the probability of 4 is just 1 over what? 12. Okay, so these are fractions. You should be able to add them. So when you add all these fractions, you get 5 over 6. Okay, and then when you put this number in decimals, you're going to get 0.833, like that. So this here will be the F5 or the cumulative probability of what? 5. All right, and then the other one there is find the probability of 5. So there now, it's not the cumulative probability, okay? It's just the probability. So they're saying probability of 5. Okay, so can you see any 5 on these random variables there? No, we can't see it. So it means the probability of 5 there would just be 0 because we can't see it there. Okay, so the probability of 5 is 0. All right, we go to B. So B, we have that. Okay, B, we have that. Okay, let me get this one. So B, we have that find the expected value of X. Okay, so remember expected value, we're just adding the product of this plus 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 the product of this. So we're going to say expected value of X will be equals to, okay, to be minus 2 multiplied by 1 over 4 plus 1 multiplied by 1 over 6 plus 3 multiplied by 1 over 3 plus 4 multiplied by 1 over 12 plus 6 multiplied by 1 over 6. Okay, so this is what we have. Okay, this is what we have. So here we are going to get minus 1 over 2. Here we're going to get plus 1 over 6. Here we are going to get plus 1. Here we're going to get plus 3 over 4. Plus here we're going to get 1. Okay, and then from there we can try to add. Okay, so 1 plus 1 is 2. And then we can add these other fractions here. Okay, so the common denominator, I'll get 6. I'm adding this, this, and this. So I'll get 6. So 2 into 6 is 3. Multiplied by minus 1, I get minus 3. This one into there, it's plus 1. Okay, so this is wrong here because 4 cannot go into 6. Okay, let's use another common denominator. So let's say the common denominator is 12. Yeah, this one will work. So 2 into 12, it's it's 6, and then multiplied by -1, -6, plus 6 into this is 2, 2 multiplied by 1, 2. Then 4 into 12, it's 3. 3 multiplied by 3, it's plus 9. Okay, so what are we going to get here now? Okay, so we are getting uh, this 2 minus 6, we are going to get -4 plus 9, okay, divided by 12. So this is going to give us what? This is going to give us 9 minus 4, it is 5 over 12. Okay, so it's giving me 5 over 12, and then I add this 1 and 1, so plus 2. So what are we going to get there? Okay, I think let's redo this. I feel like we've gone wrong somewhere. Okay, so we have -2 over 4. Okay, I'll write it as -2 over 4. Here we have plus 1 over 6. Here we have plus 3 over 3. Okay, there we have plus 4 over 12. Then there we have 6 over 6. Okay, and then let's add these now all together. So we're going to say common denominator is 12. So 4 into 12 is going to give me 3. 3 multiplied by -2 is going to give me -6. 6 into this is going to give me 2, plus that to be plus 2. This into this, it will be 4. Okay, 4 multiplied by 3, I'm going to get what? Okay, 4 multiplied by 3, I'm going to get 12. And then 12 into this is 1 multiplied by 4, I'm going to get 4. And then 6 into this is 2 multiplied by that, I'm going to get, okay, I'm going to get what? 6 into this is 2, I'm going to get 12. Okay, so now let's add these things. So this is 4 plus 2. Okay, I'm going to get 6. And then that 6 minus the 6, I'm going to get 0. So I'm just remaining with 12 plus 12, which is 24, and then divided by another 24. So this will give me 2. Okay, so that one now is the correct answer. So it means the expected value, you can write it here, of x, we're just finding what? 2. Okay, and then we look at C. C, they're saying find the variance. So remember the formula for the variance. We said the variance of x is equals to the expected value of x squared minus the expected value of x, and then we square it. So the expected value of x, we already have it there. So we just want to find the expected value of x squared. So we're going to say expected value of x squared is equals to, okay, -2, okay, squared, because you square the random variable, don't square the probability, multiplied by 1 over 4, plus 1 squared multiplied by 1 over 6, plus 3 squared multiplied by 1 over 3, plus 4 squared multiplied by 1 over 12, plus 6 squared multiplied by 1 over 6. So this is what we get, okay, when we square. So it means here we're going to have 4 and then 1 over 4. Here we still have 1 and then 1 over 6. And then there we still have, we have 9 and then 1 over 3. Okay, there we have 16 and then 1 over 12. And then here we have plus 36. Okay, and then in the brackets we have 1 over 6. Okay, so we have to add all these fractions here. Okay, and then find the final answer. So I'll just do this on my calculator to save some time. Okay. All right, so my calculator, when I punch in all these guys, it's giving me 11.5. Okay, so it means the expected value of x squared is simply 11.5. Okay, so once we have the expected value of x squared, it means we can find the variance. So variance will be equals to the expected value of x squared, 11.5, minus the expected value of x, which is 2 squared. So this will be 11.5 minus 4, which will be equals to what? Okay, this will be equals to 7.5. So 7.5 will be our variance there. Okay, so we can write it here. We say variance of x is actually equals to 7.5. Okay, because we need it in the other questions. All right, so now let's solve D. Okay, so D, we are finding the expected value of a linear equation. So they're saying expected value of 7 minus 2x. So how can we deal with this? Okay, so we have some properties that we need to know. So whenever you're given the expected value, okay, of ax, a can be any number and then plus b, something like that. Okay, so what happens here is that you distribute this e to the a, x, and the b. So we're going to say expected value of a x, okay, plus the expected value of b. So whenever you're finding the expected value of a constant, because b and a here are constant, x is the one which is a variable. Whenever you're finding the expected value of a constant, it's just that same constant. Okay, so I'm going to say this expected value of b is just b. Okay, and then here you factorize the constant, or you take the constant in front. So it's going to be equals to a, and then you remain with the expected value of x. Okay, so whenever we have such a linear combination there inside, we are going to expand it like this way. Okay, so following this same thing, I can rearrange this and I'll say this is the expected value of minus 2x and then plus 7. So you see that in this form now I have ax plus b. So the b is the what? 7. And then the a is the minus 2. So what is the expected value here? To just be expected value of minus 2x plus the expected value of 7. So this one is a constant, so it will just be 7. Then this one, the minus 2 will go in front, so it will be minus 2. Okay, and then the expected value of x. So expected value of x is 2. So I'm going to write 2 here. So what we have is 2 multiplied by the minus 2 outside there, which is just minus 4, and then plus 7. So it means the expected value, okay, of this linear function, which is 7 minus 2x, will just be 3. Okay, so always remember this property here when you're dealing with the expected values. And then I can also see there's the variance there, okay, the variance of a linear function. Okay, so it also has a special rule that we have to follow, okay, when finding the expected value of the variance of a linear. So whenever you have the variance, okay, of maybe ax plus b, okay, you can say this here, this one here is the same as, okay, we expand this as, we bring this a in front and then we square it, and then we say the variance of x, okay, plus the variance of b. So now, the variance of a constant is always 0. Okay, so this part here, when you look at the formulas in the books, it won't be included. Okay, they will just say the variance of a linear factor like that one, okay, is just equals to a squared multiplied by the variance of x. Okay, so this is what we're going to use. So I'm going to write this one here in this form. So I'm going to say the variance, okay, I'll start with the minus 2x and then plus 7. Okay, so this one is the b, this one is the a. So let's square the a, which is the minus 2 squared, and then variance of x. Okay, and then plus the variance of 7. So variance of a constant is always 0. Okay, so maybe I should not write it that way. I'd say this one is always 0. So what we remain with is just 4 multiplied by the variance of x. But remember, the variance of x, we found it was 7.5. Okay, so when you multiply that 4 multiplied by the 7.5, you're going to get 30. Okay, so this is the variance of 7 minus 2x. Right, so that's the rule that you use there. Okay, and then let's look at F, okay, which we're just finding the probability there. Okay, so they're saying F, find the probability that 7 minus 2x is greater than x. Okay, so what you do here is solve what you have inside. Okay, so put the like terms together. So this one will be 7 is greater than, then the 2x, we take it that side like this. So this will be probability of 7 greater than 3x. Okay, so now our random variable is x and it's not 3x. So we have to divide both sides by the 3. Okay, so what we end up having is this. We have the probability that x is less than, okay, 7 over 3. Okay, right, so this one here is going to be equals to the probability that x is less than, okay, so you punch that 7 over 3 on your calculator. It's going to give you approximately 2.333. Okay, something like that. So it means here we want the probability that x is less than 2.33. Okay, so what values here are less than 2.33? So we're going to say this is the same as the probability of minus 2 because it's less than this, okay, plus the probability of 1 because it's less than this. So we can't include the probability of these 3 here, no, because it's not less than 2. So let's just add the probability of these 2, then we'll be able to find our desired probability there. So we're going to say this is equals to, the probability of minus 2 is 1 over 4, plus the probability of 1 is 1 over 6. So we can add this, okay, common denominator there will be 12. So 4 into 12 is 3. So I have 3 plus, then they have 2. Okay, so this one here will be 5 over 12. So you can punch this into your calculator. You're going to get approximately 0.41667. Okay, so this is the probability that 7 minus 2x is greater than x. All right, so we are done with the first problem. We look at another one. Okay, so this is another problem under discrete random variables. Okay, so here they're saying the discrete random variable x has the probability function, okay, px, and commutative distribution function f of x, okay, given in the table below. So you've seen the table here. Okay, and then the first one is write down the value of d. Okay, so you look at the position of d. Okay, one, it's in the row for the commutative distribution function, and it's at the end. So when I was explaining the rules that you get, I said the last one here should always be what? Should always be 1, because the total probability is always 1. So when you add all the commutative probabilities, okay, you add them together, the total that you should get should always be 1. So the value of d there will just be 1. Okay, so we're going to say d is equals to 1. Okay, and then find the values of a, b, and c. So this is my a here, this is my b, and then this is my c. Okay, so we're going to use the formula for commutative uh, probability here, okay? Because this one here is the first probability, the second one, the third, the fourth, and then the fifth. And then these ones here are commutative. So it means this one here, you just get the same one, the way it is, 0.10. And then for you to get this one here, it means you added this 0.10 plus a to get the 0.26. So you're going to say 0.10 plus a gives a commutative probability of 0.26. So it means a is just equals to 0.26 minus 0.10. So it means a here will just be what? Okay, so we subtract that. We're going to find that our a will just be 0.16. Okay, so our a is 0.16 according to the formula. Okay, so let's write it somewhere. So we're going to write a is actually 0.16. Okay, so find the value of b now. Okay, so how are we going to find the value of b? So remember, b is the cumulative distribution from 1 all the way up to 3. So it means for us to find this b here, okay, we have to add this probability plus that probability. Okay, so we're going to say b is equals to 0.26 plus 0.28. So when we add these two together, what are we going to get? Okay, we're going to get okay, let me try it on my calculator. We're going to get 0.54. Okay, so this is the value of b. So another way we can use to find b is to add all these probabilities until we reach b, because it's a cumulative probability all the way up to 3. So you add 0.10 plus the A, which you found it was 0.16 plus the 0.28. So when we add this, we're still going to get this 0.54. Okay, so that one there is the value for our B. Okay, let's find the value of C. So C, where is it? Okay, so C is here. So it means for them to get this number here, which is the commutative, okay, they added B plus C. Okay, so we know the value of B, but we don't know for C. So we're going to say B, which is 0.54 plus C should be equals to 0.76. So it means C would just be equals to 0.76 minus 0.54. So C is equals to, so let's subtract here. So when you subtract here, you're going to get 0.22. Okay, so this one here will be the value of C. All right, so we are done with finding the missing values there. Okay, we're done finding the missing values. Let's find some probabilities here. So the first one, they're saying find the probability that X is greater than 4. So we're just picking the random variables, okay, that are greater than 4. So how many do we have here? We just have these 5 here. So here, the probability that X is greater than 4 is the same as the probability of 5. So what is the probability of 5? It's 0.24. Okay, the probability of 5 is 0.24. So we are done there. Right, so now let's look at D. So D, they're saying two independent observations, X1 and X2, are taken from the distribution of X. Find the probability that X1 and X2 are both odd. So how can we solve this question? How can we find that both X1 and X2 are odd? Okay, so first of all, we need to calculate the probability that the distribution of X is odd. So the distribution of X is what we've been given here. So to find the probability, okay, that this X is odd, we're just going to add the probability for the odd numbers here. So 1 is an odd number, 3 is an odd number, and 5 is an what? Odd number. Okay, so let's add their probability. So it will be 0.10 plus 0.28 plus 0.24. Okay, this will be equals to, and then when we add this, I'm getting a 0.62. So this is the probability. Okay, this is the probability that X, this X here is odd. But the question here is find the probability that X1 and X2 are both odd. So since both this X1 and X2 are coming from this same distribution of X, okay, it means that the probability of X1 being odd, okay, it will be the same as the distribution where it's coming from. So it will be 0.6 as well, 0.62 I mean. Okay, and then the probability that X2 is odd will also be equal to this because it's coming from the same distribution. So it will be 0.62 as well. Okay, and then now to find the probability, okay, to find the probability that X1 and X2, okay, are both odd, we're just going to multiply the probability of X1 and X2. So it will be 0.62 multiplied by 0.62. Okay, so when we punch this into the calculator, okay, we're just going to find 0.3844. Okay, so this is the probability that both X1 and X2 are odd. Okay, so we can write it somewhere here. So X1 and X2 are odd. The probability is 0.3844. Then let's look at the last question on question 2. Okay, so the last question is E. So the last question is a conditional probability. So here they're saying given that X1 and X2 are odd, we know its probability is this. Okay, find the probability that the sum X1 and X2 is 6. Okay, so we're going to say let the event that the sum of X1 and X2 is 6 be A. So plus X2, if this sum is equals to 6, we get that to be the event A. And then let's say event B will be that X x1 and x2 are odd. Okay, so what we are calculating here, okay, is the same. Find the probability that the sum of x1 and x2 is 6, okay, given that they are odd. So we are finding the conditional probability of A given B. Okay, so this is the probability that the sum of x1 and x2 is 6, given that x1 and x2 is odd. So this one is the same as the probability of A intersection B divided by the probability of what? B. So this is going to be equals to, so the sum, okay, of x1 and x2 should be 6, given that those x1s and x2 are odd. So when you go here, the sum that can be odd is 1 and 5, okay, 3 and 3, and then 5 and 1. So we're going to say the probability of 1, 5, okay, plus the probability of 3, 3, plus the probability of 5, 1, and then we divide all this by the probability of odd. Okay, so the probability that x1 and x2 are odd is just this one here. Okay, so now how do we find this one here, the probability of 1, 5? So here, this one here is the same as the probability of 1 multiplied by the probability of 5. This one is the probability of 3 multiplied by the probability of 3. This one is the probability of 5 multiplied by the probability of 1. So this one here will be 0.10 multiplied by 0.24 plus 0.28 for 3 multiplied by itself, okay, then plus 0.24 multiplied by 0.10. So we are dividing all this by the probability that x1 and x2 are odd, which is 0.3844. All right, so from there, what are we going to get? Okay, so just punch in these values onto the calculator. They should be able to give us the figures. So this one here will be equals to, so if I punch in whatever is on top, okay, and then I divide it with what I have down there, I'm getting the final answer as 0.329. So this is the probability, okay, that the sum of x1 and x2 is 6, given that the probability of x1 and x2, they are both what? Odd. All right, so now let's go to question 3. All right, so question 3, they're saying the random variable x has the probability function, this one here, okay, for the values of x, 1, 2, 3, 4. Show that the value of k is equals to 0. So how can we show that? Okay, so remember we said the summation, okay, of all the probabilities, okay, the summation of all the probabilities here is just the same as what? It's just the summation of all the probabilities over all the values of x should always be equals to what? 1. That's what we said. Okay, so it means here, okay, I can find the probability of 1, 2, 3, 4 by just replacing where there's x here, I put the value of x there. So the first one will be 1 squared over k plus 2 squared over k plus 3 squared over k plus 4 squared over k is equals to 1, because we're adding all the probabilities, right? Okay, and then from there, we can just multiply both sides by k. So all these k's in the denominator will cancel. So our 1 squared, which is 1, plus 2 squared, which is 4, plus 3 squared, which is 9, plus 4 squared, which is 16, is equals to k. Okay, so when I add all these, I'm getting what? So this is 1 plus 4, 5, 5 plus 9, I'm going to get 14, 14 plus 16, I'm going to get 30. So 30 is equals to k. So we have shown that this one is true. Okay, so we found the value of k. It means the probability function, we can now write it as, okay, x squared divided by 30. Okay, and then from now, we can find the other probabilities there, or the other questions. So the next question here, they're saying, find the probability that x is not equal to 4. Okay, so the probability that x is not equal to 4, it's the probability of 1 plus the probability of 3 plus the probability of 2. Okay, so the probability of 1 is just 1 over 30 plus the probability of 3, it will be 3 squared on top there, which is 9 over 30, plus the probability of 2, it will be 2 squared on top here, so it will be 4 over 30. And then you just add these, so it will be 30, 1 plus 9 plus 4. Okay, so this is 14 over 30, which will give us what in decimals? Okay, so 13 over 30 is going to give me 0.4667. Okay, so this is the probability that x is not equal to 4. Okay, and then I'll find the exact value of the expected value of x. Okay, so there we can come up with a diagram. Okay, we can come up with a diagram. So we're going to say, let this be our probability distribution in tabular form. So I have x, and then I have the probability of this x. So 1, 2, 3, and then 4. Okay, so what is the probability of 1? Just replace where there's x squared, we put 1. So that is 1 over 30. This one here is 4 over 30. This one here is 9 over 30. This one here is 16 over what? 30. So to find the expected value of x, remember, we said it will be adding the product of the variable with its probability. So 1 multiplied by this, I get 1 over 30 plus 2 multiplied by this, I get 8 over 30 plus 3 multiplied by this, I get 27 over 30 plus 4 multiplied by 16. Okay, so 4 multiplied by 16 is what? That's like 24 plus 24. No. It's like 32 plus 32, right? Yeah, so that one would be 64. Okay, so that would be 64 over 30. So we just add all these now. What are we going to get? Okay, that will be the exact value of um our that will be the exact value of our expected value of x. Okay, so since we have the same denominator there, we can write 30 there. And then since we have the same denominator here, it means on top we're going to have 1 plus 8 plus 27 plus 64. So when we add all these, what are we going to get? Okay, so 1 plus 8, it's 9. 9 plus 27, it's 36. 36 plus 64, it's 100. Then I'm dividing by 30. So what am I going to get as my expected value of x? Okay, I'm going to get 3.3333. So this is the expected value of x. Okay, this is the expected value of x. And then now we are asked to find the variance of x. Okay, so the variance of x, it means we need that expected value of x squared. So we'll keep this expected value of x somewhere. So we're going to say expected value of x is equals to 3.3333. And then now variance of x is the same as the expected value of x squared minus the expected value of x and then squared. So it means here what we have is, okay, what is the expected value of x squared? So we'll be squaring these x's now, but multiplying with the same probability. So it will be 1 squared, okay, 1 squared multiplied by 1 over 30. I'm still going to get 1 over 30. Then plus 2 squared is 4. And then 4 multiplied by 4, that would be 16 over 30. Okay, 3 squared, it's 9. 9 multiplied by 9, I'm going to get 81 over 30 plus, then this one is 4 squared. Okay, so 4 squared is 16. 16 multiplied by 16 is going to give me what? It's going to give me, okay, let me punch it on my calculator. So 16 multiplied by 16 is going to give me 256 over 30. Okay, so we can add this, since we have the common denominator there, we can just add the numerators there. So it will be 1, okay, I'm doing it on my calculator, 1 plus 16 plus 81 plus 256. Okay, I'm going to get 354. So it's 354 over 30. Okay, so you can find that as a decimal. So if you find that as a decimal, what am I finding on my calculator? I'm finding 11.8 like this. Okay, so that is my expected value of x squared. So once you have that, you can now find the variance. So we're going to say the variance is equals to the expected value of x squared is 11.8 minus the expected value of x squared. Okay, so that is 3.3333 and then squared. Okay, so just punch this onto your calculator. Right, so when I do that, I end up with 0.6889. So this one here will be my variance of what? X. Okay, that will be my variance of X. Right, so we are now left with question E. So question E, they're saying given that y is equals to 3x minus 1, okay, find the expected value of y squared. Okay, so this one here won't be difficult. So we just have to follow what I was saying. So they're saying y is equals to 3x minus 1. Okay, that's what they're saying. And then they want us to find the expected value of y squared. So what we do is we have to find y squared. Okay, so if y is 3x minus 1, then y squared would be this same 3x minus 1 multiplied by itself. Okay, so this would be 3x multiplied by 3x to be 9x squared. 3x multiplied by minus 1 to be minus 3x, minus 1 multiplied by this, minus 3x, minus 1 multiplied by 1 plus 1. So it means the y squared is actually equals to 9x squared minus 3. We can add those, so it will be minus 6x and then plus 1. Okay, so that's what I have. So it means there, okay, it means there, I'm just finding the expected value of this whole thing here. So it will be the expected value of 9x squared minus 6x plus 1. So we said we can expand this to, okay, the expected value of 9x squared, okay, and then minus, or we can say plus, first of all, the expected value of minus 6x, and then plus the expected value of what? 1. Okay, and then from there we can come up with this. Okay, so from there we can say we take the 9 outside, so to be expected 9 and then expected value of x squared. Remember, we already found the expected value of x squared. Okay, so expected value of x squared, we found it was 11.8. And then plus this one here, it will be minus now, in fact, outside, because the minus 6 will go out. So it will be minus 6 expected value of x, and then plus the expected value of a constant is always 1. Okay, so what we have there will be 9, 11.8 minus 6, 3.333 plus 1. Okay, so when you put now this into the calculator, okay, what are we going to get? So I'm getting my final answer as 87.2. So this one here will be the expected value of y squared. Okay, so we found the expected value of y squared in terms of the what? The x. All right, so we are done with that question. Next, we look at question 4. Okay, so we are still looking at discrete random variables. All right, so question 4, they're saying the discrete random variable x can take only the values 1, 2, 3, 4. For these values, the probability function has been given as this guy here. Okay, so show that 5a plus 2b is actually equals to 30. Okay, so how are we going to remember that the summation of all the probabilities will always give you what? 1. So that's how we're going to find it. So the summation of the probabilities, okay, for all these random variables here should be 1. So if I substitute 1 into this, I'm going to get a multiplied by 1, okay, which is just a, plus b divided by 60 plus. If I substitute 2 there, it will be 2x plus b divided by 60. If I put 3, it will be 3a plus b divided by 60. If I put 4, it will be 4a plus b divided by 60. Okay, so since this is the summation of all the possible values of the random variable, I'm going to say this should be equals to 1. Okay, so we can see here that we have the same denominator. So we can just add whatever is on top. So a, why did I write x here now? That should be a. Okay, so this one is a. So a plus 2a, 3a, plus 3a, 6a. 6a plus 4a, I'm going to get 10a. Then plus b to be b plus b plus b plus b. So that's how many b's? 4 b's. Okay, and this should be equals to what? 1. Okay, and then from there, what can we do? Okay, we can multiply both sides by 60. Okay, we can multiply both sides by 60, or we can just cross multiply. So this is over 1. Okay, so this one multiplied by this one, I'm going to get 10a plus 4b is equals to 60 multiplied by 1 to be 60. Okay, and then from there we can divide throughout by 2 to get the desired equation that we want to show. So if I divide here throughout by 2, I'm going to get 5a plus 2b is equals to 30. Yeah, so you can even see that this one here is what we are required to show there. So the equation comes out on its own, as long as you do the correct thing. So this will be our equation 1. Okay, and then they're also saying that given that f of 3 is equals to 13 over 20, find the value of a and b. Okay, so it means here from this f of 3, we are going to get another equation. Okay, and then we have 2 equations. Okay, so we solve that equation with this one here simultaneously to find the value of a. So remember, f of 3 is the same as the probability that x is less than or equal to 3. So this is the same as the probability of 1 plus the probability of 2 plus the probability of what? 3. Okay, so the probability of 1 is just a plus b over 60 plus the probability of 2 is 2a plus b over 60 plus the probability of 3 is 3a plus b over 60. So this is goes to a plus 2a, that is 3a, plus 3a to be 6a plus, and then this one will be b, that will be 3b divided by 60. So this is what I have. And we are saying that this one here, since it's the cumulative probability up to 3, is equals to what? 13 over 20. So I'm going to write 6a plus 3b over 60 is equals to 13 over 20. Okay, so what is remaining there is just to simplify that equation there. Okay, just to simplify that equation there. Right, so let's try to simplify it. Okay, so I'm going to say let's multiply both sides by 20. Okay, just for simplicity. So if I multiply by 20 here, okay, to be 20, and then I have my 6a there plus 3b over 60 is equals to, if I multiply this side by 20, okay, it is 20 multiplied by 13 over 20. So it means this 20 and this 20 will cancel. So I'll just remain with 13. Okay, and then here I can divide. So 20 there it's 1, 20 there is 3. So what I have is 6a plus 3b is equals to, if we can put this one over 1, it will be 1 multiplied by this. That's why I'm getting this. And then this 3 multiplied by the 13 there. Okay, so 3 multiplied by the 13, what are we going to get? We're going to get 39, right? We're going to get 39 like that. Then we can divide throughout here by 3. So the first one, it will be 2a plus b is equals to 13 into 39. 3 into 39 to be 1, 3. Okay, so that will be the second equation that we're going to get. So we're going to call this as our equation 2. And then what we had here will be our equation 1. So for us to find the value of a and b, we just need to solve those 2 equations simultaneously. Okay, so let's make b the subject here. So b will be equals to 13 minus 2a. This will be my b. Okay, and then from there, we are going to say, let's substitute this value of b into this one. So it will be 5a plus 2. Then where there's b, I put 13 minus 2a is equals to 30. So what I get is 5a plus 26 minus 4a is equals to 30. So 5a minus 4a, I'm going to get a plus 26 is equals to 30. So this will be a is equals to 30 minus 26. Okay, so it means my a will just be equals to 4. All right, so I found my a to be 4. I can find my value of b as well. So my value of b, I just use that equation there. So it says b is equals to 13 minus 2, 4, because the a is the 4 there. So this is 13 minus 8. So this will be 5. Okay, so it means the value of b will just be equals to 5. Right, so we found the value of b, we've found the value of a. Okay, let's move on and solve question C. Okay, so since we found the value of a and value of b, so it means our probability mass function there will be is equals to 4x plus 5 over 60. So this is our probability mass function. Okay, so now the question on C here, okay, they are saying, given also that y is equals to x squared, okay, find the cumulative distribution of y. So what are we going to do there? First of all, we need to find the probability distribution of x, okay, just the x. So I'm going to draw up a table here. Okay, so this is my x, and then this is my p of x. So we have 1, 2, 3, 4. So 1, 2, 3, and then the 4. So this is what I have here. Okay, this is what I have. So from here now I can find the probabilities here. So if my x is 1, then I place here. Okay, it's just going to be 9 over 60. If my x is 2, to be 4 multiplied by this, it will be 8. 8 plus 5, that will be 13 over 60. Okay. If it's 3, it will be 12 plus 5, that will be 17 over 60. Then if it is 4, it will be 16 plus 5, that will be 21 over 60. So what I've drawn here is just the probability distribution of x. Okay, it's just the probability distribution of x. So now, on this C here, they're saying given also that y is equals to x squared, find the cumulative distribution of y. Okay, so how can we find the cumulative distribution of y? Okay, how can we find the cumulative distribution of this y? Okay, so remember from the definition, we said if we're finding the cumulative uh, probability, okay, or the cumulative distribution of maybe x, we say this is the same as the probability of x being less than or equal to a certain value of x. So here we want to find the cumulative distribution of y, okay, but y is being given as x squared. So we're finding the cumulative distribution of y, which is the same as the probability that x, okay, is less than or equal to y. Okay, but we know that y is less than or equal to this y here is the same as x squared. So here I can put x squared. So it means we're just finding the cumulative distribution of this guy here. Okay, so what I'm going to do here is just draw up another table that I'll put in terms of y. Okay, in terms of y. So that table is going to be like this. So we're going to say, okay, so here I'll put the cumulative of y, and then here I'll put y. So the y values, I'm going to get them using this formula here. So if x is 1, y is 1, using this formula. If x is 2, it means y will be 4, right? Okay. If x is 3, y will be 9. If x is 4, y will be 16. Okay. So the probabilities here will just be getting the cumulative distribution from here. So what is the probability, okay, that this y is equals to 1? Okay, we're going to get the same 9 over 60. Okay, and then now when you go to the next here, we are finding the probability or the cumulative probability of this y. So it means for us to find this one, we have to add the probability of the probability that is coming next to the first probability that we got. So here the cumulative probability of this 4 will be 9 over 60 plus 13 over 60. So that will give me a 22 over 60. And then the cumulative distribution here of y, okay, the cumulative distribution of 9 here will be 17 over 60 plus this 22 over 60. So that one is going to give me 39 over 60. Okay, and then the cumulative probability of 16 will be this 39 over 60 plus 21 over 60. So that one will just give me a 60 over 60. Okay, so you can see that in the final column here, we're ending up with 60 over 60, which is 1. So the cumulative distribution there, okay, or the cumulative probability in the last column there, okay, it should always be 1. Okay, so it means we are correct here. So what we have drawn here will be the cumulative distribution of what? Y. All right, so let's look at the last question, which is on the binomial distribution. Okay, so here they're saying a random variable x has the distribution that follows a binomial, okay, with n12 and then p. So this 12 there, it indicates the number of trials. So number of independent trials is just 12, and then the probability of success is just p. Okay, so A, given that the probability of success is 0.25, find the probability that x is less than 5. Okay, so here you can use two methods. You can use the binomial tables. Okay, you can just use the binomial tables, or you can use the binomial formula. Okay, so the PDF of a binomial distribution, okay, is given as the probability of x is equals to n choose x, and then p to the power x, and then 1 minus p to the power n minus x. So this 1 minus p is the same as q, and q is known as the probability of failure. So this is the PDF, not the PDF, I'm sorry, the PMF, okay, of a probability function. So if they say they are asking us to find the probability that x is less than 5, they mean we have to find the probability of 1 plus the probability. In fact, the probability under the binomial starts from 0. So you start from the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of what? 4. So you add all these probabilities, the one that is going to give you the probability that x is less than what? 5. So we're going to be using this formula here. Okay, so this x here is the one that is changing here. So here we have it being 0, there it's 1, just like that. And we're going to be using this formula. So we've been told that the n is actually 12. Okay, and the probability of success, P, is 0.25. So this means that the probability of failure, which is Q, or 1 minus P, will just be 0.75. So how do we find this 0.75? We just say 1 minus the P. The P is 0.25. You're going to get your Q. Right, so this will be equals to N, which is 12, choose 0 for the first one here. Okay, and then it will be 0.25 to the power 0, and then 0.75 to the power okay, n minus x. So 12 minus 0, that will be 12. Okay, so we are going to be moving in that fashion. So I can erase this part. Okay, so I'm going to say plus. The next one to be 12, 1. Okay, and then 0.25, and then I have 1, 0.75, and then I have 12 minus 1, which is 11. And then plus, the next one will be 12, 2, and then I have 0.25 to the power 2, and then 0.75 to the power 12 minus 2, which is 10, plus, here I have 3, so it will be 12, 3, then 0.25 to the power 3, and then 0.75 to the power 12 minus 3, which will be 9. Okay, plus the last one, which is 4. So it will be 12, 4, and then 0.25 to the power 4, and then multiplied by 0.75 to the power 12 minus 4, which will be 8. So you add all this, okay? So for the sake of time, I'm just going to punch this into your calculator. So just look for the combined symbol on your calculator. So you do 12 combined 0 multiplied by 0.25 to the power 0 multiplied by 0.75 to the power 12, and then you say plus, you repeat again, just at the same process. Okay, so let me do that and see what I'm going to get here. Okay, so once I do all that, I'm getting the final answer as 0.8424. So this will be the probability that X is less than what? 5. Okay, so you just have to add all these here. So you punch them from the calculator. All right, so the next one, I'm not going to show it, okay? I'm just going to use the probability tables, but you should try it out. So the probability that X is greater than or equal to 7. So whenever you say greater than, you have to convert it into a less than, okay? So we're going to say, this here is the same as the probability, okay? It's the same as 1 minus the probability that this X is less than 7. Okay, and then this one here, you repeat what we did. We start from 0 all the way up to 7. Okay, but I'm not going to do that. You should try it out, okay? But the probability of this from the binomial tables, okay? The probability of this is the same as the probability of X being less than or equal to 6, okay? So from the binomial tables now, I can get this value. Okay, so it's giving me 0.9875. 857. Okay, so when I subtract, I want to get 0.0143. So this is the probability that X is greater than or equal to 7. Okay, but you can try it out. Right, so when you try it out, you can text me. My number is in the description. I'll be able to guide if what you're doing is correct or wrong. Right, let's look at B. So on B, they're saying given that the probability of X is equals to 0 is 0.05, find the value of P to 3 decimal places. Okay, so here we use the binomial distribution PMF. So we said it was N combined X. So the X is 0, so it is 12 combined 0, then 0.25, 0, and then 0.75 is the power 12. They're saying this here should be equals to this, which is 0.05. So now they want us to find the value of P. In fact, here the P should not be there, okay, because they want us to find it. So the probability has not been given there. So this P and this one will go. So just write these in terms of P. Okay, so remember here we're at P, and then here we're at Q. But we said Q was equals to 1 minus P. So I'm going to write 1 minus P here so that I have a uniform thing. So this is 12 combined 0. So any number combined 0 is always 1. And then any number to the power 0 is 1. And then I will remain with it. 1 minus P, okay? And then to the power 12 is equals to 0.05. So how am I going to solve that now? Okay, so from here you can multiply both sides by power 1 over 12. Okay, so what we have is this. And then to the power 12 is equals to 0.05. So what I'm going to do, I'm going to multiply this side by 1 over 12. Even this power, I know there's 1 there, multiplied by 1 over 12. So what I'm going to get is 1 minus P is equals to, okay, the 0.05 and then to the power 1 over 12. Okay, so what am I going to do with this one here? Okay, so there are a lot of ways that you can use to solve this one here. So let's take the P this side, and then this side we take it that side. So we're going to end up with P is equals to 1 minus 0.05 to the power 1 over 12 like that. Okay, so from there you can apply ln to both sides, okay, and then the power will drop. But the final answer there, you're just going to get 0.2209. Okay, so that would be the value of P there. Right, and then let's look at C. So C, they're saying given that the variance of X is 1.92, find the possible values of P. All right, so when it comes to the variance of a binomial distribution, it's simply given as NPQ. So NP, and then the Q, you can write it as 1 minus P. Okay, so we're saying this variance is 1.92, and then the number of trials is 12 from this one here. So the N is 12, but the P I don't know. So it will be 12P minus 12P squared. Okay, so we can take all of them to the left side. We have 12P squared minus 12P plus 1.92 is equals to 0. So this is a quadratic equation. So we just solve it using the quadratic formula, okay? Find the value of P. So it means this one here is acting as my A, B, and then C. Remember the general form of a quadratic function? Okay, so now this one is in terms of P. So I can write AP squared, okay, plus BP, then plus C. So it's in this form. So this is my A, this is my Y. So I'm going to write P is equals to, okay, minus B plus or minus the square root of B squared minus 4AC, and then divided by what? 2A. So this is going to be equals to minus B, to just be minus 12 plus or minus the square root of this guy squared. So it will be minus 12 squared minus 4 multiplied by A, which is 12, multiplied by C, which is 1.92, okay, divided by 2, multiplied by 12. So this is what we have. Okay, so from there, what are we going to get? We're going to get 12 plus, and then under the root there, we're going to have 144. And then the other ones, we can multiply them. Okay, so 4 multiplied by 12 is going to give me what? 4 multiplied by 12 is going to give me 48. Okay, and then I'm multiplying by 1.92. Then I'm dividing all this by 2 multiplied by this, which will just be 24. Okay, so that is what I have. So on top there now, okay, I can subtract these and then I take the square root. Okay, so when I do that on my calculator, add that, I subtract that and then take the square root, I'm getting 7.2 and then divided by this. Okay, so it means the values of P will be, okay, the values of P will be, I'll erase this part. The values of P will be, P is equals to 12 plus or minus 7.2 is equals to, divided by 24. So it means here we have P is equals to 12 plus 7.2 divided by 24, or P is equals to 12 minus 7.2 divided by 24. Okay, so from this guy, we're going to get 0.8. Then from here, we're going to get P is 0.2. So we have two values for P. P can either be 0.08 or 0.2. Right, so we are done for today. Okay, have a blessed night. And if you need more videos, okay, you can register with us, and then you're going to find a full video on the tutorial sheet where I got these questions from. We're going to find it on our website. Okay, so these are questions from the Unilus second semester tutorial sheet. So you can find them on our website, and then you can learn. We also have videos on all the individual topics. Okay, so math, physics, chemistry, and biology. You can register for whatever course that you want. Okay, have a blessed night. Welcome to this video. This is question 6 from tutorial sheet 6. Okay, so this question is on the binomial distribution. So they're saying it is estimated that 4% of people have brown eyes. In a random sample of size n, the expected number of people with brown eyes is 5. Calculate the value of n. Okay, so this is on the binomial distribution. So this one here, where they're saying it's estimated that 4% of the people have brown eyes, simply means that the probability of success is 4%. Okay, and the 4% is the same as 0.04. Just divide by 4 by the 100. So this is the probability of success. Okay, and then they're saying the expected number of people with brown eyes. So meaning the expected value of x is just equals to 5. And then calculate the value of n. So we know that the expected value, okay, under the binomial distribution is calculated as np, where n, okay, is the sample size, and then p is the probability. So the probability, I mean the expected value we've been given, it's 5, k is equals to, and then the n is what we want to find, but the probability of success is just 0.04. So for us to find the value of n here, what are we going to do? We're going to divide both sides by 0.04, giving this side 0.04. So it means my n will just be equals to 5, okay? 5 divided by the 0.04. So we are going to get 125. Okay, so it means n, or the sample size, will be 125. Okay, if the expected value is 5 and the probability of success is 0.04. Right, so B, let's look at B. So B, they're saying the expected number of people with brown eyes in a second random variable is 3. Find the standard deviation, okay, of the number of people with brown eyes in this sample. So we know that the variance of x is actually equals to npq. That is when you're under the binomial distribution. The variance is just simply the multiplication of this. So n is the probability of success, and then this q is the probability of failure. So the probability of failure, which is q, is the same as 1 minus p. So this will be 1 minus p, like this. Okay, so now let's get what we've been told. Here they're saying the expected number of people with brown eyes is 3. And we remember the expected number of x is just equals to np. So this np here is the expected number. We're saying it's 3. And then 1 minus. This p doesn't change. It's still this 4%. Okay, 4% is 4 over 100, which is the same as 0.04. So I'm putting 0.04. So let's find the variance. So when I multiply this, okay, I'm going to get 2.88. So this is the variance. Okay, but the question here was find the standard deviation. So for us to find the standard deviation, we always have to find the variance. Okay, so we're now going to say the standard deviation is just the square root of the variance, which is 2.88. So it means the standard deviation here will just be the root of 2.88, which is 1.697, like that. So this is the standard deviation. And we are done with question 6. So we look now at question 7. Okay, so read it together, we understand it. So they're saying a drugs company claims that 75% of patients suffering from depression recover when treated with a new drug. Okay, a random sample of 10 patients with depression is taken from the doctor's record. Okay, so A, write down a suitable distribution to model the number of patients in this sample who recover when treated with the new drug. Okay, so how are we going to come up with the model there? So we're going to say, since there are only 2 possible outcomes, okay, it's either the patient, when he's treated with this new drug, it's either the patient recovers, okay, or does not recover, okay. The suitable distribution, whenever you have a fixed probability of failure and the fixed probability of success. So in this case, the probability of success is that the patient recovers, and then the probability of failure is that the patient does not recover, right? So whenever you have fixed probability of failure and fixed probability of success, okay, we are going to say the suitable distribution to model the number of patients who recover, okay, will just be a binomial distribution. So we're going to say x will follow the binomial distribution, okay, with parameters n, p, where this n is the number of patients, okay, in that research, and then P is the probability of success. So in this case, we've been told that 75% of the patients recover, okay, from depression. So it means P is equals to 75%, which is the same as 0.75. So it means the probability of success is 0.75, okay? And then the N, we've been told is what? 10 patients. Okay, so in this case, the suitable model was that X will follow a binomial distribution such that the N is 10 and the P is 0.75. So this will be the model that this particular case will follow. Okay, right, and then we should know that the PF, or the probability under the binomial function, is given as N. Let me write it properly. It's given as N combined X, okay? And then we have P, which is the probability of success to the power X. And then we have 1 minus P, which is the same as Q, to the power N minus X, okay? For all the values of N starting from 0, 1, 2, all the way up to infinity. Okay, so this is the formula that we're going to be using under binomial. Okay, so we can look at B now. So since we know the model now that it's the binomial, here on B, they're saying, given that the claim is correct, find the probability that the treatment will be successful for exactly 6 patients. Okay, so it means we're just finding the probability of 6. So remember the formula. Here should be X and then P to the power X, then 1 minus P, which is the same as Q, to the power N minus X. So we're using this formula. So the X now is 6. Okay, the N is how many patients? 10. So it will be 10, 6. The probability of success is 0.75. Okay, this 75%. So this 1 to the power X, which is 6. And then what is 1 minus this? You're going to get 0.25, which is our Q, or 1 minus P, and then to the power 10 minus 6, which is 4. Okay, so what is left now is just to punch this value onto the calculator, and then you get your answer. So if I punch this into my calculator, I'm getting the probability as 0.146. Okay, so we are done with question 7. Let's look at question 8. Okay, so question 8, they're saying a disease occurs in 3% of the population. Okay, A, state any assumptions that are required to model the number of people with the disease in a random sample of N as a binomial distribution. Okay, so under the binomial distribution, we usually have 2 assumptions. Okay, one is that the probability of having the disease is independent. Okay, so we're going to say probability of having the disease is independent. So this is the same, this is the first assumption that we make whenever we are looking at the binomial distribution. Okay, so that will be the first assumption. And then the second one is that the probability, okay, of having the disease is constant. Okay, so these are the only assumptions that you need under the binomial distribution. So we've answered A, and then B, they're saying use this model. Using this model, find the probability of exactly 2 people having the disease in a random sample of 10 people. So it means N is 10. What is the P? P, they said 3% of the population. So that is 3 over 100. So that will be 0.03. So it means my Q will just be equals to what? K will be 1 minus 0.03. Okay, so here we're finding the probability that exactly 2 people have the disease. So we are using this formula, remember? So probability of 2, nx, okay, the x is 2, the n is 10, and then the probability of success, 0.03 to the power 2, and then the probability of failure, 1 minus 0.03 to the power what? 10 minus 2, which is 8. So you have to make sure that these powers always add up to what you have there, which is 10. Okay, so from there, what are we going to find as our probability? Okay, what are we going to find there as our probability? Okay, so when I punch this, it's giving me 0.03174. Okay, so you just do 10 combined 2 multiplied by 0.03 to the power 2, and then you can put this in brackets. You say 1 minus 0.03 to the power 8. Okay, you're going to get this answer here. So this is the answer we get on B. Okay, let's look at C. Okay, so on C, they're saying the mean and variance of the number of people with the disease in a random sample. They're saying find the mean and the variance of the number of people with the disease in a random sample of 100 people. So how are we going to find that mean? Okay, so remember this is the binomial distribution. Okay, so whenever we want to find the mean under the binomial, we just multiply the sample size with the probability of success. So the sample size now is 100. And then the probability of success, remember, 3%, which is 0.03. So it means the mean here, or the expected value, will just be 3. Okay, and then the variance under the binomial distribution is just n, p, and then multiplied by q. Or we say multiplied by 1 minus p. So this q is the same as 1 minus p. So it means here I have 100, okay, multiplied by 0.03 multiplied by 1 minus 0.03. So just punch this onto your calculator. Okay, so my calculator is giving me the variance of 2.91. So this is the mean, this is the what? The variance. Right, let's look at the last question on question 8. Okay, so the last question, they're saying a doctor tests a random sample of 100 people. So the sample is 100 people for the disease. He decides to offer all patients a vaccination to protect them from the disease if more than 5 of the sample have the disease. Okay. He decides to offer all patients a vaccination to protect them from the disease if more than 5 of the sample have the disease. Okay, using a suitable approximation, find the probability that the doctor will offer all patients a vaccination. Okay, so here we're just simplifying the probability that x is greater than 5. Okay, so whenever you have a greater than, you have to change it into a less than. So this will be the same as 1 minus the probability that x is less than or equal to 5. Okay, so here you apply the binomial distribution. So it means this one here is the same as 1 minus it. Okay, the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5. Okay, so you find all this the same way we did when we find the probability of 2 here. Okay, but I'm not going to write all that. Okay, you can also get this value from the table, okay, for the binomial distribution. So the probability that x is less than or equal to 5, okay, for the p-value of this and the sample size of 100 here, okay, the sample size is 100, is simply going to give me a 0.9161. So here just subtract, you get 0.0839. So this here will be the probability that the doctor will give everyone there a what? A vaccination. Right, so thank you so much. I will see you in the next video. Welcome back to the last part of tutorial sheet 6. Today we are solving question 9, question 10, and question 11. So here they're saying the random variable x has the discrete uniform distribution, okay, being given by this formula that we can see here. Right, so A, they're saying given that the expected value of x is 5, show that the value of n is 9. So here you have to know the formula for the expected value, okay, under the uniform distribution. So under the uniform distribution, the expected value of x is given as n plus 1 divided by 2. So this is just going to be equals to n plus 1 divided by 2. And then they're saying this expected value is 5. So I'm going to put is equals to 5. Okay, so this will end up being n plus 1 is equals to 10. Okay, and then from there, we can say n is equals to 10 minus 1. So n is equals to 9. So we've shown that n is equals to 9. Okay, and then so it means this probability mass function now is p of x is equals to x is equals to 1 over 9. So that's what we have. Okay, and then b, they're saying find the probability that x is less than 7. So the probability that x is less than 7 is the same as probability of since x is starting at 1 here, so probability of 1 plus probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5, okay, plus the probability of 6. So these are the ones that are less than 7. So according to this one, okay, whatever value that you have here, the probability function remains constant. So this one here for the probability of 1 to just be 1 over 9, plus even this one will be 1 over 9, plus even this one will be 1 over 9, plus even 1 over 9, plus 1 over 9, plus 1 over 9. So we have 6 1 over 9s. So it's the same as 6 over what? 9. So we divide that. 6 divided by 9, I'm going to get 2 over 3. So you can leave it as a fraction if you want to calculate it as a decimal. So this is the probability that x is less than 7. Okay. Then let's find the variance. So the variance, you also just have to know the formula. So the variance under the uniform distribution, okay, the variance under the uniform distribution is given as n squared minus 1 divided by 12. So this is going to give us, okay, n squared, n is 9. Okay, n is 9. We've shown that the n is 9. So 9 squared minus 1, and then divided by what? 12. So this one here is going to give me what? Okay, so it will be 81 minus 1, which is 80 over 12. So this is going to give me 80 over 12, which is the same as 20 over 3. So you can find it as a decimal if you want, but this will be the variance. So you see that under these different distributions, okay, you have to know the formula for the variance and the mean. So the mean we said was given by n plus 1 divided by 2. This is the mean of a uniform distribution. Okay, and then the variance is given by this formula. So if you don't know these formulas, it means you won't be able to answer the questions. Okay, so make sure you get familiar with the formulas. And then we look at question 8, which is under a Poisson distribution. Okay, so a Poisson also has its own formulas. Right, so the probability under a Poisson is given as e to the power mu, okay, multiplied by mu to the power x divided by x factorial. So this mu here is the mean, okay, the average. Right, so let's read the question now. So they're saying the results of a medical study showed that some among patients treated with drug X had later developed migraine headaches. The study revealed that the occurrence of the migraines followed a Poisson distribution with the mean 8, okay, incidents per year. So that's why we're going to put the 8 there. Okay, so A, find the probability, okay, that there are exactly 2 cases. So we're finding the probability of 2. So this would be e to the power minus 8, okay, and then I have 8, okay, e to the power minus 8, and then I have 8 to the power 2 divided by 2 factorial. Okay, so this one here to be e to the power minus 8 multiplied by 64 divided by 2, which is the same as e to the power minus 8 multiplied by 32. So just punch in now this value onto your calculator, okay, should be able to get approximately 0.0107. That's according to my calculator. Please confirm with your own calculator as well. All right, so that's how we'll answer A. And then B, they're saying more than 4 cases. Okay, so it means we're finding the probability that X is greater than what? 4. So whenever we have a greater than, we have to convert it into a less than. So this one here is the same as probability of 1 minus probability that X is less than or equal to what? 4. Okay, so under a Poisson distribution, the values of X start from 0, 1, 2, until whatever value that you end at. Okay, so it means here, this is the same as the probability, 1 minus the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of what? 4. So we are subtracting 1 minus the probability of all this summation here. So this will be equals to 1 minus, okay? So what I have here, if I have 0 there, it means wherever there's X here, I'm putting 0. Okay, but remember, this e to the power minus 8 will be there and the 8 there. Okay, so since each one of these, this one, this one, this one, and this one, and this one, will have e to the power minus 8, I can factorize the e to the power minus 8. Okay, so what I will remain with will just be this to the power this, and then divided by that. So at first here, it will be 8 to the power 0 divided by 0 factorial, plus if I have 1, to be 8 to the power 1 divided by 1 factorial, plus if I have 2, to be 8 to the power 2 divided by 2 factorial, plus 8 to the power 3 divided by 3 factorial, plus there to be 8 to the power 4 divided by 4 factorial. So this is what I have. Okay, so what is remaining? This has to simplify this expression. So let's create some space on top here. Okay, so we're going to say this probability is equals to 1 minus, so in the brackets I have e to the power minus 8. Okay, so 8 to the power 0 divided by 0 factorial. 0 factorial is 1. 8 to the power 0 is 1. So I have 1 plus. This is 8 to the power 1 divided by 1 factorial. That would be 8. Okay, 8 to the power 2 divided by 2 factorial. It will be 16 divided by 2, which is just 8, plus this will be 3 factorial, which is 6. 8 to the power 8 to the power 3 is what? Okay, so you just multiply there 8 times 8 times 8. So 8 times 8 times 8, give me 512 divided by 6 plus 8 to the power 4. Okay, 8 to the power 4, it gives 4096 divided by 4 factorial, which will be 4 multiplied by 3, which is 12, multiplied by 2, 24. Multiplied by 1 still remains 24. So this is what I have there. Okay, so what remains is just to punch this value into the calculator. Okay, and that will be it. Okay, that will be it when we do that. All right, so I'll say, I'll solve it like this. I'll say 1 minus, and then here I'll say this multiplied by 1. Okay, it's going to give me about 0.0003335. Okay, plus this multiplied by 8. It's going to give me 0.00268 plus e to the power minus 8 multiplied by this. Okay, so I'm going to get 0.0107 plus no. I think I've made a mistake. So this one multiplied by this, I'm getting this. Okay, this one multiplied by this, I'm getting this, and then this one multiplied by this, I'm getting okay, I think I forgot one value here. All right, okay, let me just punch it into the calculator, all the values together. Okay, so when I punch in everything here, okay, I'm getting 1 minus, when I punch in all this, I'm getting 0.996. Okay, there's a 0 here. So as I subtract this, I'll just get 0.9004. So this is the probability that more than 4 cases will occur. Okay, so I'm still using this same formula, so I'll not erase it. At most 6 cases. So that is the probability, okay, that X is less than or equal to 6. Okay, so this one, you can try it out, but if you use the tables, the cumulative Poisson values tables, should be able to get 0.31 3, 4. So what you do here is you find the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6. Okay, so it means in this formula, you replace 0 there, you place 1, you place 2, just like that. So the final answer that you're going to get is this. Okay, and then the last one is saying find the probability that there is no such case. Okay, so that no such case, it means the probability of 0 or between 3 and 5. So between 3 and 5, we have 3, 4, and 5. So it means we are adding the probability of nothing plus the probability of 3 plus the probability of 4 plus the probability of what? 5. So this one here is going to be 8. It's going to be e to the power minus 8. Okay, and then 8 to the power 0 divided by 0 factorial plus e to the power minus 8. Okay, multiplied by 8 to the power 3 divided by 3 factorial plus e to the power minus 8 multiplied by 8 to the power 4, 4 factorial plus e to the power minus 8 multiplied by 8 to the power 5, 5 factorial. Okay, so this one here, let's just punch it into the calculator. Okay, so when I punch all this into the calculator, I'm getting the final answer as 0.178. So this one here will be the answer for this last one. Okay, let's look at the last question in this tutorial sheet, which is question 11. Okay, so on question 11, what are we finding? Okay, on question 11, what are we finding? So question 11, they're saying, okay, question 11, where is question 11 now? Okay, so they're saying the random variable x has the probability function, okay, which is given by this. So this is a piecewise function. So I'm sure you learned the piecewise function when you're doing the topic functions, okay? So it means there are two functions here, okay? If x is 1, 2, 3, we're using this. If x is 4, 5, we're using this, okay? So where k is the constant. So find the value of the constant. So we say the probability, okay, when we add all the constants, it's always equals to what? To 1. Okay, so we can even draw like a distribution table here just to make it easier for us to visualize. So here I'm going to have the value of x. Okay, so x can be 1, can be 2, can be 3, can be 4, can be 5. And then this will be the probability px. So if x is 1, we're using this. Okay, so I'll substitute 1 where there's the x there. So what am I going to get? I'm going to get k. If x is 2, I'm going to get 2k. If x is 3, I'm going to get 3k. But if x is 4, it means I'm using this other formula here, which is down, this one. So if x is 4, then it will be k, and then 4 plus 1. So that will be 5k. So I'll write 5k here. Then if it's 5, it will just be 6k. So now, since they are claiming that this is a valid PDF, it means when I add all these probabilities that I have, I should get 1. So if I add k plus 2k, okay, plus 3k, plus 5k, plus 6k, what I get should be 1. Okay, so when I add all this, I'll get 17k is equals to 1. So it means k will just be what? 1 over 17. Right, so k is 1 over 17. So the value of k, we can write it here, 1 over 17. Okay, and then from there, we can answer the other questions. So the other questions, they're saying, find the exact value of the expected value. So the expected value, remember, we're just multiplying the random variable with its probability. So the probability is 1 over 17. So what I'm going to do here is, okay, because here it will be 1 multiplied by k plus 2 multiplied by 2k plus 3 multiplied by 3k plus 4 multiplied by 5k plus 5 multiplied by 6k. So this is what I have, right? So I'll factorize the k. and then I'll remain with 1 plus. So here, if I move the k to be 2 multiplied by 2, that would be 4. Plus here to be 3 multiplied by 3, that would be 9. Plus here to be 4 multiplied by 5, that would be 20. Plus 5 multiplied by 6, that would be 30. Okay, so what I have here is the k, we know it's 1 over 17. And then in the brackets there, what are we going to have? Okay, so maybe I haven't written it properly. So the k, this one, okay, we're saying it's 1 over 17. And then in the brackets, we just have to add the numbers. So this is 5. Okay, this is 50. So this is 55 plus 9. So 55 plus 9 is 64. So it means the expected value, the exact one is 64 over 17. Okay, so that would be the expected value there. Okay, so we can write it somewhere here. We're going to write the expected value of x is actually 64 over 17. Okay, and then now they're saying find the variance. Okay, I'll show that correct to 3 significant figures, the variance is 1.47. So what are we going to do? So remember, when finding the variance, if I can write the formula here, we have to find the expected value of x squared, right? Okay, and then we say minus the expected value of x and then squared. So here, if I want to find the expected value of x squared, I can square this. It means here I'll square this, I'll square this, square this, square this, and then square this. So what I have is the k, I'll factorize it, but the k is 1 over 17. So what I'll remain with is 1 squared, which is 1, 2 squared multiplied by this to be 8, plus 3 squared is 9, and then multiplied by another 3, that will be 27, plus, okay, this will be 4 squared, which is 16, multiplied by 5, that will be 80, plus 5 squared, 25, multiplied by 6. Okay, what is 25 multiplied by 6? To be 150. Okay, so now I just have to add whatever I have in the brackets here. So whenever when I add whatever is in the brackets, I'm going to get 266. So it will be 266 multiplied by 1 over 17. That will just be 266 multiplied by divided by 17, I mean. So this one here will be the expected value of x squared. Okay, so it means from there now we can find our variance, or we can show that it's indeed this value. So variance of x will be equals to the expected value of x squared, which is 266 over 17, okay, minus 64 over 17 squared. Okay, so what we're going to get when you compute this will just be 1.474. So we've shown that correct to 3 significant figures, the variance is simply 1.47. So you punch this into your calculator. Okay, so once you do that, now you can use it to find the last question. So this is our variance here. So remember we said the variance of ax plus b is the same as a squared variance of x. Okay, so now I have the variance of 4 minus 3x. So I'll write the minus 3 in front and then plus 4. So this will be the same as minus 3 squared. Okay, and then I have variance of x. Okay, so the constant there, just ignore it. Right, disappears from the equation. So this will be 9 variance of x. So the variance of x is what? Variance of x is 1.47, I mean. So this is 9 multiplied by 1.47. That would be 13.3. So that would be the variance of this guy here. So we are done with all the questions in this tutorial sheet. Okay, I hope you enjoy it when you'll be revising for your test or your quiz or the final exam.